Hi there, and thanks for tuning in. Today we're looking at lesson 14.4E, or extension, repeating decimals. Today we're going to be writing down 6 things. Let's go ahead and get started. The first thing we know is that repeating decimals can be written as fractions, so that's exactly what we're going to be doing today. Normally we've gone from fractions to repeating decimals, and now we're just flipping the script. We're going from repeating decimals and writing them as fractions. Here are the following steps to write a repeating decimal as a fraction. And this is probably not going to make a lot of sense when you're writing it down at first, but when you see me do an example, hopefully that'll make sense to you after that. Step 1, you're going to write the original equation x is equal to d, so d represents whatever decimal. Then you're going to be multiplying that number for step 2 by a power of 10, whether that you're multiplying both sides of the equation by 10 or 100 or 1000, however many repeating digits there are, that's how many times you multiply by 10. So if there's one repeating digit, you multiply by 10 once. If there are 2 repeating digits, you multiply by 10 twice, or 100. So maybe that's something that you can consider when you are solving these questions. Okay? And then the third step is you're subtracting the original equation. So remember, your original equation would be x is equal to whatever decimal, and then step 4 is solving for x. Let's go ahead and take time now to pause the video here so you can write down this 4 steps, and once you're done, click play so you can see how it's done. Alright, so the first one I'm going to show you is just an example with one digit repeating, which means I'm going to be multiplying both the sides eventually by 10. The first thing you're going to do, and I'm going to label these as my step 1, 2, and 3, and 4. Step 1 would be to write the original equation, so x is equal to 0.4 repeating. Okay? Step 2 is to multiply both sides of the problem by the power of 10, however many digits are repeating. Since there's only one repeating digit, I will multiply each side by 10. Okay? So I'm going to multiply x by 10, and I'm going to multiply 0.4 by 10. That is going to look like this. X times 10 is 10x, and 0.4 repeating times 10 is going to get me 4.4 repeating, because I'm basically just moving over the decimal one time to the right. Okay? The next step is super important. Step 3 said to subtract the original equation from the multiplied one. So we're going to be subtracting this original equation up here. So I'm going to subtract x and 0.4. Here's what you want. You want this to change to a whole number, if possible. Okay, and that's exactly what's going to happen here. 4.4 minus 0.4 is just going to give me 4. Okay, which is great. That's what I needed. 10x minus x gives me 9x. So there's my step 3. And then last but not least is step 4 when you solve for x. What I need to do to solve for x here is just divide both sides by 9. So x is equal to 4 divided by 9, or 4 over 9. Because remember, we wanted a fraction in simplest form, and 4/9 is already in simplest form. Okay? If you need to rewatch this part, please do that. What we're going to do now is go ahead and try one on your own. Okay? So you're going to pause the video here. Try to write 0.5 repeating as a fraction in simplest form using the 4 steps, and then click play when you're ready to check your work. Okay, so the very first step is we're going to write the equation. So we're going to write x is equal to 0.5 repeating. Then my step 2 is to multiply both sides by a power of 10, depending on how many numbers are repeating. In this case, one number is repeating, so I'm multiplying 10 to the first power, so just by 10. Okay, this is my step 2, transforming it to 10x is equal to 5.5 repeating. Step 2, going into step 3, is subtracting the original equation. Remember, here's the original equation. So minus x minus 0.5 repeating, and I will get 9x is equal to 5. Last but not least, in step 4, going from 3 to 4, is I'm solving for x. So I'm just dividing whatever x is attached to. It normally would be a 9 or a 99 or 999 every time you divide. Okay, so keep that in mind. x will be equal to 5 over 9. That is in simplest form, so that would be my answer. One way you can be checking these before your test, obviously, because you won't be able to use a calculator on your test, you can check with a calculator. And if you just type in top number divided by bottom number, you should get the 0.5 repeating. Okay? Here's one that you're going to try on your own too, and notice there's two things different. Obviously there's a negative in front of your answer, so maybe just ignore the negative for now, but just make sure that your final answer has a negative in it. The other thing you want to keep in mind is now there are two repeating decimals. There are two repeating decimals this time, so keep that in mind whenever you're multiplying by a power of 10. Maybe you're not multiplying just by 10 anymore, maybe you're multiplying by 100, okay? Let's go ahead and pause the video now so you can try this question on your own, and once you're done, click play so we can check our work. Alright, the first thing we did for number 3 is write down the original equation. So x is equal to 0.23 repeating. Okay. Step 2, I'm going to multiply by a power of 10 depending on how many repeating decimals there are. Since there are two repeating decimals, I'm going to be multiplying by 10 to the second power, which is equal to 100. Okay. So that's timesing by 100 on both sides. 100 times x is 100x. 0.23 times 100, that just means moving the decimal 2 more times to the right. So that's 23.23 repeating. Okay, here's what happened. 0.23 repeats, right? 2, 3, 2, 3, 2, 3, la la la. Multiplying by 100 sends the decimal 2 times to the right. So that's how we got 23.23, 23, 23, 23, etc. We only need to focus on those two decimals that are repeating for now. Step 3 is to subtract the original equation from both sides. So here I am subtracting the original equation. X is equal to 0.23 repeating. Minus x minus 0.23. 100 minus x is 99. And 0.23 take away from 23.23. These basically cancel out, so you're left with a whole number, which is your main goal. You want to try to get a whole number here as possible. Sometimes that won't happen, and you'll see that later on in number 6. Then step 4, we're going to solve for x. So divide both sides by 99, and x is equal to 23 over 99. That cannot be simplified anymore, so we are done right there. Okay, noticing a lot of your answers have 9s on the bottom. That's totally fine. Oops, I forgot the negative. So negative 23.99. Sometimes you won't have a 99 on the bottom because you simplified. There will be one thing that you need to simplify in these notes today, so let's go ahead and keep checking these. Here is number 4. Number 4 can be done the same way you did number 3, except maybe just ignore the whole number at first, and then bring it back in. So maybe just think of 0.25 repeating, and then bring back in once you're done. Okay, so let's go ahead and pause here. Try this one on your own, 1.25 repeating, and then click play when you're ready to check. Alright, step 1, we'll write the equation. I'm going to write it as 0.25 repeating, just because the only difference is I'm going to have a whole number attached to my fraction, so a mixed number. Then I'm going to multiply both sides by 100, so getting you to practice those two repeating digits. So I'll get 100x on the left side, and 25.25 repeating on the right side. Step 3, subtracting the original equation. So I get 99x, oops, this should be 25, is equal to 25. Divide both sides by 99 is my step 4. And then x is equal to 25/99. It cannot be simplified, so there's my final answer for number 4. Number 5, again, oops, sorry boys and girls, we're bringing back the whole number at the end. Good job, Miss Mullins. You should actually say 1 and 25/99, okay? So don't make that mistake that I just made. Cool? All right. Number 5, again, bringing back that whole number at the end. Let's go ahead and pause it here. Try this one on your own, and once you're done, click play. Alright, so step 1, writing the original problem. I'm going to write x is equal to 0.35, and I am going to remember to write my whole number this time. So I went ahead and just wrote my answer down here at the bottom. Step 2, multiplying each side by 100, because I have 2 repeating decimals. So I'll get 100x is equal to 35.35 repeating. Step 3, subtracting the original problem. 99x is equal to 35. Step 4, solve for x. Divide by 99. So my fraction is 35/99 because I cannot simplify it anymore. So basically I just need to write 2 and 35/99 as my answer. Okay? Step 6 is a little bit different. You are still going to multiply both of these by 10 because there's only one repeating decimal. Okay? So let's go ahead and try this one. You will need to simplify, so remember to simplify your answer. Let's see if we can figure this one out, okay? Go ahead and pause right now. Try number 6, and once you're done, click play to check your work. Okay, you should have noticed that this one was a little bit different because there is one repeating decimal, but it happens later on. Okay, so this is not the exact same thing as number 3 and what you did in your notes before. So number 1, step 1 is to write your fraction or write your repeating decimal equation. And then step 2 is to multiply by the number of repeating digits. I only see 10 or 1 repeating digit, so I'm going to multiply by 10. This will still work if you multiply by 100 or 1,000 or 10,000. You just have a little bit more simplifying to do at the end. Okay, that's going to give me 10x is equal to 2.3. And I'm going to also, since this 3 keeps going, I'm going to say 2.33, okay? And that'll make sense here in a moment. Then for step 3, I'm going to subtract the original equation. Here's the reason why I wrote an extra 3, so I can match up the decimal place value. If I wouldn't have written the extra 3, a lot of people try to write a 0 here, but that's not true. Because all these threes repeat, there should be a 3 there. Okay? When I subtract, I'm going to get 9x is equal to 2.1. So this is where our issue is going to come in here, but we can fix that easily once we're going here. Because 3 minus 3 is 0, 3 minus 2 is 1, and 2 minus nothing is 2. Step 4 is to now solve for x. I'm going to divide both sides by 9, but I'm not going to stop here because 2.1 over 9 is not a true fraction. A fraction has to have a whole number on the top and a whole number on the bottom. One way you can do this and fix this is if you multiply both of these by 10, you will get rid of that decimal because 2.1 will now change to 21 and 9 will change to 90. Now we can simplify. 21 and 90 can be both divided by 3. So 21 divided by 3 is 7, and 90 divided by 3 is 30. So my final answer for number 6 is 7/30. Okay? You will have some of those like that on your homework, so if you want to come back and rewatch this section, you can. That is going to complete our answer. Here's just more of it written out very nice and neat. That's going to complete our notes for today. Thank you so much for tuning in, and we'll catch you next time.